Good morning, and thank you to those of us who are able to join us this morning, and apologies to anybody that had trouble getting in through the Eventbrite link. It looks like Eventbrite servers are down this morning, so timely that we're doing our Fraunhofer webinar, which is usually on networks and reliability and efficacy of use of the internet and whatnot. So without further ado, we'll go ahead and get started, and then just know as there are bings coming in, there's probably going to be quite a bit of late arrivals as we get our Zoom links out to everybody. So Fraunhofer, the South Carolina Fraunhofer Alliance was created several years ago as a initiative through SC Competes. That's a partnership between our Department of Commerce and SC Competes and Fraunhofer USA. And we've had the pleasure over the last couple months of having monthly webinars focused on several different important topics that pertain to not only our industry cluster, but our academic institutions, K-12 programs, tech colleges, and even more. So I will not take up any more of our time, but I would like to introduce Marcel Schaefer, who's a research director for Fraunhofer USA and is located here in South Carolina. And is working on our South Carolina Fraunhofer USA Alliance. So Marcel, I'll turn it over to you.
Thanks, Adrian. Hello, good morning also from my side. Welcome to the final webinar for this year, for 2021. We already have a good lineup for 22. We have laser for automotive or lightweight production technology or quality inspections coming up, so stay tuned on that. Before we jump into this topic today, I want to remind the audience of this fantastic relationship between Fraunhofer and the state of South Carolina, providing a substantial dollar-for-dollar cash match fund for projects within the SC Fraunhofer USA Alliance. In other words, half of your project budget for Fraunhofer and the academic research partners would be paid by this cash match fund. Again, please reach out to me or Suzanne Dickerson. Everyone here should have our contact information by now or will be provided after the webinar, if that's of interest for you. Okay, today's topic is huge. Discussions about 5G can be heard everywhere. It's a great pleasure to introduce one of those guys who are spearheading practical approaches of how to make use of this new technology. Thomas Magadans is the director of the business unit Software-Based Networks at Fraunhofer FOKUS since 2003, and as with many of the leading experts at Fraunhofer, Thomas is also a professor. He's a professor at the Technical University of Berlin for Next Generation Networks since 2004. He's been in the ICT field for over 30 years, both on the research side as well as on the application side, and also as an independent technology consultant. During his time, he developed many international recognized prototype implementations of global communication standards. Actually, the Fraunhofer 5G Playground represents the world's most advanced open 5G testbed. We'll hear more about that later. Now his interest is in software-based 5G networks, especially today's topic, 5G campus networks. More specifically, his current research targeting the 5G evolution to 6G, and we will hear or get an outlook on that later as well, including core RAN integration, satellite, non-terrestrial networks, 5G, 6G integration, as well as AI, ML-based or artificial intelligence, machine learning-based 5G, 6G network control and management. Big topics need big players. Thomas, we're very happy to have you with us today. The stage is yours. First, we screen a video. I forgot to mention that. First, a video, and then Professor Thomas Magadans will present.
The industry places highest requirements on the communication network. It should provide security against cyber attacks, be robust so that there are no expensive outages, and ideally ensure real-time communication to control robots wirelessly without delay. Also, communication networks may provide automated guided vehicles, short AGVs, on the factory plant with up-to-date information about the environment. To meet these requirements, a private customer-specific 5G campus network is ideal and supports the digital sovereignty of companies. 5G enables robust, fail-safe communications for networking intelligent machines and devices in the industrial Internet of Things and the implementation of distributed production. This will allow industrial production and service processes to be carried out more effectively and efficiently. The Fraunhofer Institute's IPK and FOKUS offer a cross-site campus network in Berlin for their customers and partners from industry and research to test 5G hardware and applications. Industrial application scenarios are implemented in the 5G infrastructure of IPK's machine park, connecting people, machines, and processes in real time. As an application example, an automated guided vehicle transports spare parts. The vehicle is equipped with a robot arm on which a camera is installed and detects the environment via a laser scanner. The environmental data is transmitted from the AGV to the edge cloud, the local cloud computing, via the campus network. Sophisticated algorithms on the edge cloud use this data to determine the position of the vehicle in the workshop, detect obstacles, and determine an optimal path to the target position. The calculated control commands are then transmitted from the edge cloud to the vehicle via the campus network. The interaction of 5G, edge cloud, and artificial intelligence guarantees the processing of the data in real time and thus enables the autonomous control of the transport system on the company premises. For 5G coverage, base stations of different manufacturers were installed in the hall. The antennas in the factory work floor cover the frequency range for campus networks in Germany, 3700 to 3800 megahertz. The campus network is controlled by a software-based core network located at Fraunhofer FOKUS, which is only a few kilometers away. The two institutes are connected via fiber optics. The Open 5G core runs in the lab and data center of the software-based networks business unit of Fraunhofer FOKUS. It manages the entire communication between the AGV and the edge cloud, including authentication and security. The Open 5G core is 3GPP standard-based and vendor-independent. Another advantage of campus networks for industry is that the data for applications is stored and processed locally at the edge. To realize this, the software modules of the Open 5G core can be split. The management of the communication stays at Fraunhofer FOKUS, while the communication of the AGV is maintained within the IPK factory. This is realized by the so-called local breakout capability of the Open 5G core. This ensures high processing speed and low latency thanks to the short communication paths. The Open 5G core is also available for licensing to enable portable applications and individual company networks worldwide. Our joint campus network enables the software-defined factory of the future. Every component of the 5G infrastructure is interchangeable and can be replaced with custom-designed components such as antennas, software modules, or sensors. Using predefined factory processes, companies can test, together with Fraunhofer in joint projects, the functionality of their components in a real environment and verify their impact on the 5G infrastructure.
Great video, and again to everyone here in the audience, yes, we had some problems with Eventbrite this morning, so everybody who has missed something, beware, you get the whole video recording shortly after the event. I hope people are still jumping in. I get emails all the time now. We're working on that. But now, turning over to Thomas, please tell us more about 5G and 6G.
Oh. Okay, first of all, hello from Berlin in Germany, and it's early afternoon, so I'm still awake enough to present some hot stuff to you, and thanks for the warm welcome. So I'm going to share my presentation, which later on you also are getting to read up what is told by me at this point in time. So, okay, understanding the potential of 5G campus networks, and particularly the main motto of this talk, build up your own network. So this is becoming possible in these days. And here on this view graph, you see the FOKUS building in Berlin, and it shows and indicates somehow the coverage area of our antenna systems. What you don't see is the garage, which is in the bottom in the underground, but in principle this is where we can try and play the technologies in our environment, but more on this a little bit later. So then, what do I want to talk to you? And in principle, I want to motivate that 5G is these days quite a lot of discussed around the globe. It is promoted since many years, and now we see really global deployments. We somehow see particularly the potential of this technology, but it is not yet fulfilled in the sense that all the nice things we have seen on glossy brochures we can see today in our hands, but it's going to come. And the reason for this is that 5G is a software-based technology, and we can consider it as a toolbox which could be used, and different components could be used to create your own connectivity infrastructure for specific application needs. And I will talk in the next slides a little bit more on the functional capabilities. However, what I want to stress here in this talk is from what you typically see by your service providers, network operators, namely fixed wireless access and some kind of better bandwidth in the city centers. There is not too much innovation. And here particularly, we see that verticals are playing an important role. So we have seen that particularly in 5G applications, we have seen manufacturing, healthcare, special places like arenas and fairgrounds, harbors, but also mining and oil place platforms, safety environments, agriculture, transport, logistics. So this means, in principle, this is something which is related to an already very important business domain. And here 5G, of course, can provide the connectivity part. And this, to a large extent, is bound to very specific locations where this kind of service should be provided. Also, we see specific requirements for the data, which is application specific, which typically should not go through the country, but should somehow stay in specific areas for security reasons. So these local campus enterprise networks somehow have popped up in the past. The story started with 4G in reality, but now with 5G, we see a technology which really provides the coverage, the bandwidth, and particularly the low latency capabilities. We will elaborate a little bit later in this presentation. So in principle, also one important point, I don't read all the bullets on these slides, and I skip quite a lot of slides. So it's a big pile of paper, which you can later look at. For me, it's more important to convey the main messages. So in principle, when we talk about local networks, wireless networks, of course, we have to also take into account what is the spectrum which is available and could be utilized for this. And in the past, we have seen that Wi-Fi technologies and unlicensed LTE technologies are typically used inside the factory plants or enterprise networks. Now with 5G, we see also new kind of frequency regimes where we see also local frequencies for companies, for instance, or enterprises in Germany, UK, and France, and other places. You have your CBRS structure in place in the US. So this means this is something which is becoming more and more popular, and people become knowledgeable. And on the other hand, we currently see that the second generation of 5G technology hits the market. So the techie term for this is 5G standalone architecture, in contrast to a non-standalone architecture. And the main difference is that 5G standalone doesn't care about LTE and backward compatibility. It is a technology which makes use of the new radio access network technologies, high efficiency, low latency. So if you really want to go for the super duper applications, then you need the 5G standalone technology. And this is available or becoming mainstream available in these months. And from here, you can really start playing. So Germany has become a pioneer in this context of private 5G networks and campus networks because we have dedicated spectrum assigned for this kind of use case. And on the other hand, we also have a quite prominent pre-standardization group, which is called the 5G ASEA. And this is closely bound to the local industry. Meanwhile, this pre-standardization group is visited by people from all over the world. So we have Japanese, Korean, and European members in this pre-standardization discussing how to move forward. So we as a research institute are very closely working in 5G ASEA. We work with the local players on technologies, and we have, as Marcel already introduced, a strong footprint and recognition in playing around with technologies. So we build prototypes of upcoming standards, and we are typically delivering these prototype implementations to network operators, to vendors, equipment vendors, to integrators, but also to academic institutions all over the world. So we have a 5G core network, which is an important component in a 5G architecture because this links all the radio access systems and the applications in the end. And this is more than 100 times licensed around the globe. And when I'm talking about the globe, it is really deployed in the US, in Asia, in Europe, in Africa. So tier one operators and key research organizations are making use of this technology, which could be adapted to very specific needs, being it that we need an infrastructure for very advanced application use cases, or is it just technology evolution for radio access networks or edge computing infrastructures, and so on and so on. And we think that this technology might be of interest for you, and this is why we are talking here about this hot stuff. So very briefly, this is not a 5G tutorial, but at least we need to understand why is 5G so interesting. It is, in contrast to 4G, an infrastructure which should enable very different application use cases. Very often these days we talk about the Internet of Things and the industrial Internet of Things. And here particularly, this is an umbrella for lots of business domains where lots of money is generated. And this is particularly automotive, logistics, e-health, manufacturing. So this is here on this view graph, industrial applications, but we also see quite a lot of these enterprise and private networks in the context of agriculture, mining, and so on. So plus the classic mobile broadband connectivity as we know it in order to facilitate much better over-the-top services. The interesting part is that this system is, so to say, the successor of 4G and particularly also interworks with Wi-Fi infrastructures and also very nicely with fixed and optical network infrastructures. So it's really the new unifying infrastructure for whatever should be connected, it could do so. When we take a look at the standardization, which typically happens in 3GPP, and the International Telecommunications Union is, so to say, setting the floor for this kind of standardization. The standardization happens in steps, and these steps are called releases. So the first real release for 5G has been called release 15. So this is what we currently see in terms of products being deployed by the different network operators. This is only optimized for multimedia applications. So this is the top of this triangle, which is used to explain very different use cases. The very interesting and sexy use cases very often associated with 5G is low latency communication and ultra low latency and reliable communications, which typically means the internet of, let's call it, you have the internet on your fingers. So it's this kind of real-time communications in order to control robots and surgery machines and hospitals and so on. On the other hand, we see massive IoT, massive machine type communications. So lots of devices which are aggregated in a certain area, and they have to be connected probably with different focal points on energy savings and so on. So you see there are many different aspects of the applications, and particularly the lower part of this triangle is now going to be addressed with the new technology, the release 16 and 17 standardized products, which adhere particularly also to the standalone architecture of 5G. So just to make this clear, then we have to understand that 5G is a software-driven architecture. And the software-driven architecture means here it's a cloud-based architecture. However, when we particularly want to provide low latency communication, we somehow have to get the whole data transport and control closer to the place where it is needed. And in this context, we have also seen in the past the rise of edge computing. So it's basically a distributed cloud, and the edge computers or the edge computing centers are typically very close to the place where certain things happen. Very often they are even on-site, a factory plant or in an arena, in order to keep the data and the communications control locally. Last point is we talk about really fancy end systems. It's not anymore just the smartphone, but it's basically machines which need to be interconnected, and therefore we need also some kind of programming of those machines. And in case we want to provide an end-to-end connectivity for certain applications, we need to understand that we have a toolbox in our hands where we can place the control in the cloud, in an edge server, and not necessarily too much into the machines, but also the machines become smarter in this context. So we talk about a programmable end-to-end architecture, and technologies like network virtualization, software-defined networks are playing here really an important role, and this is the main difference to previous network generations. When we talk about this kind of local communication, edge-based communication, then we have to think twice whether, and this depends on the use case, do we need this kind of connectivity just in a factory? Or do we need this in a set of factories which somehow need to be interconnected? Or do we need this kind of connectivity in between factories because for logistical applications? And what this view graph just should illustrate is there are many different use case scenarios where communication sometimes really has to be bright on a national, to be realized on a national level. But sometimes it is also very good when we talk about mining or oil drill platforms. This kind of communication to a large extent really happens locally, and we just need a backhaul link in order to bring data in and out, but the connectivity happens in a specific site. So when we see fancy use cases like e-health, entertainment, or smart factories, energy control, then, and this is an old slide, somehow we always see that this typically happens at very specific places. So this means we really have to understand that there is a reason why in this context, location, a campus, a kind of local network matters. So therefore, since a while, the industry was very hungry for 5G. Network operators were just starting to roll out 5G technology. They had to use what was available. So release 15 technology, good for multimedia, but not good at all for industrial use cases, particularly for low latency communication. But we have seen prototypes becoming available. We also, for this new technology, we also have seen that network operators are not really able to address the whole spectrum of applications, being it e-health applications, manufacturing applications, agriculture applications, mining applications. Particularly, these specific areas have very specific application needs. And therefore, this notion of enterprise private networking popped up. And particularly, the opportunity was seen that making use of 5G could enable these fancy new use cases. And the question is, who is in the end building this kind of network? Is it the enterprise itself? Is it an integrator? Is it a vendor? Or is it even a network operator? Because to deploy high advanced 5G technologies, even prototypes at a certain site, might be possible. But when you have to provide coverage all over the country, then of course you have to wait for mainstream technology, which is not that customized as it is needed for all these different use cases. So particularly companies like Siemens and Bosch have strongly forced some kind of grouping in terms of, let's discuss how we can build local networks, particularly to enable a better connectivity in the factories. And basically, this is what we talk about. I don't go into the details. I just grabbed left and right some market reports, and you see here at least some illustration that this kind of private networking market is ramping up slowly but continuously, and it depends on what you are looking for. Particularly the manufacturing domain is considered as the driver for this kind of deployment scenarios, because here the biggest benefit is seen in terms of making the production lines more efficient in the future. Nevertheless, you see also energy and utilities and logistical applications, which are not predestined, not ideal for this kind of network. However, when we think about the Amazon distribution hubs, then we have already a local context in which then a logistical application also makes quite a lot of sense, making use of the capabilities of 5G. So I don't want to go into the details, but at least there are some reports out which reveal that there is a growing number of companies providing equipment for private campus networks, and lots of organizations starting to play and deploy these kinds of networks, not necessarily already commercially, but at least as prototypes in order to see what is possible by using 5G technology to interconnect devices to realize smart applications. So what has happened in Germany? And basically, this is why we are here. We have already a couple of years now in discussions with the stakeholders from the industry that there is a need for these local networks. And there have been tremendous discussions how this could be done, because we need spectrum for this kind of network setup, particularly when we are not in a rural area, but somehow in industry parks, and some people, different companies, want to set up their own network. We all know the problems which arise when we are setting up Wi-Fi hotspots and they are too close to each other that they might disturb. And so for 5G, the idea was really there should be dedicated frequencies. And these frequencies are particularly, as mentioned before, in the 3.7 to 3.8 gigahertz spectrum, which is a high efficient spectrum in terms of capacity. It is not ideal for a long reach, because the lower the frequency, the more coverage you have. However, the more coverage you have and the lower the frequency is, you don't can transport anymore that much data. So these are the vanilla frequencies in 5G, and lots of operators in Germany really have roared against this decision. However, the Bundesnetzagentur, the authority assigning the frequencies, has decided for this, and now companies can buy these frequencies. It's a fair regime. For 1 square meter of area for 10 years, you typically would pay 20,000 euro just to make use of this kind of frequency. So there is a calculation in place. It's in one of these slides. I don't go further on this. Anyhow, I mentioned this 5G Alliance for Connected Industries and Automation, 5G is here. And basically, this is the who is who. So lots of network operators, integrators, the OT companies like Bosch and Siemens, manufacturing companies like Cougar, so robot companies, and media companies. So it's not only manufacturing, but everyone who is really interested in this new local private networking infrastructure is joining this group. And so it's a lot of drive currently in this group. And we are also, as an academic organization, working close with the industry part of the 5GSC. They have published quite some interesting white papers. I provide some links on these white papers so that you can digest this, but at least they have looked for what are the requirements in the manufacturing environment in terms of connection density, battery lifetime of devices, position accuracy, security, reliability, and so on. Because one thing is clear, when we want to control a construction plant, or better saying a manufacturing line, then we can have outages of the network infrastructure, because this costs a lot of money. So in principle, they have captured this kind of requirements and motivated that there are lots of factories which might be interconnected with a backhaul infrastructure, because this is, for instance, all Volkswagen factory plants. By the way, also the car manufacturers are obviously part of 5GSC. And then they identified different options for how to implement a public network or a non-public network infrastructure. In fact, here in this documentation, it is called non-public networks, as in the standards, because people don't like the term private, because this kind of network might also be provided by a network operator very dedicated for a specific customer. But there are different options to implement such an infrastructure in terms of who owns the antenna, who owns the infrastructure, is the core network part of the factory plant infrastructure, or is this somehow hosted by the network operator close by or in the cloud? Very unlikely, because we have to cope with low latency. But there are many different scenarios which are elaborated in order to show that there's a variety to implement your own network infrastructure. So I skip the details of those reports here, but at least what is said, and I think this is quite interesting, this last line of bullets here, that the chief revenue officer at Verizon Business is estimating the mobile private network market something in between $7 and $8 billion by 2025. And particularly the market, the overall market, is half of this is in the US. So this means, obviously, it seems to me that there are lots of opportunities in your states over there in order to make use of this kind of technologies. And also here, and this is taken from the TM Forum white paper, you see different options how this kind of network infrastructure might be implemented. When I'm now talking on a campus network, I'm much focused on the left-hand side of this picture, basically an autonomous private network. So it's not something you are going to rent from a network operator, but something which either you are building yourself because you have a cool and strong IT and networking department, or you go to some kind of smaller service company which is building this infrastructure for you and running it. So there are different options to do so. But basically, this is a real ramping up market, which we will see in the very near future, particularly also fueled by these current ongoing Open RAN discussions about digital sovereignty of the networking equipment in your country. So, okay, what have we done? And basically a little bit looking backward. So since many, many years, we have what I call the dirty hands of hacking. We have been the voice over IP pioneers. So we built the SIP Express router, which was used by all network operators in the past around the globe to play around with this fancy new voice over IP technologies. We have been sponsored by Intel to implement an open source IP multimedia system, which basically was a 3G control platform for IP-based carrier networks. We then understood that particularly over the top, the Skypes and the Facebooks pop up, and therefore the core network is becoming quite important. So we built an evolved packet core network, which we licensed, and we departed from open source. we licensed this technology also roughly 100 times, and then we created a spin-off company. And finally, we sold the spin-off company to Twilio. And this is probably a company you might know in the US. So this means Fraunhofer is building technology and also able to license and sell it off to bigger giants in the industry. So since a couple of years, we are building this Open 5G core because we want to be really ahead of technology developments. And I will have the time here, but you will see in the slides, we are now also implementing already 6G prototypes, which are dominating international research at this point in time. We have testbed infrastructures. You have seen it in the video. So we call it the 5G playground. So this is our building. And we bring also test beds to the customer. Yeah? So this means here we have a software which could be very flexibly distributed, aggregated in an edge server if needed. And this is our building with different, let's call it focal areas, garage for assisting self-driving cars. We have a manufacturing infrastructure. And here we go for low latency communication. You see particularly also fancy lorries in front of the building. So we also go for nomadic network setups for safety, firefighting, agricultural purposes, where we use a satellite backhaul for the connectivity backhaul, but the local communication is a 5G advanced communication. So this means some years ago, we have already been at Hannover Fair and controlled this kind of robot. So there's a fancy video you can see here. This is what we did 2019. In these days, we are more advanced, and you have seen this in the video. We FOKUS, we are a software institute, but there is a factory institute 2-3 kilometers in distance from our place, IPK. And here we are particularly having set up a radio access network, a remote radio access network for us. We are controlling it from Fraunhofer FOKUS building. Here is our edge server and the core network. And you have seen these applications which we are doing, namely to control these AGVs and particularly making use of this visual component in order to grab specific things. So, and this means also we create connectivity maps, and these are the areas where these AGVs are allowed to travel in order to secure the humans which are walking alongside. This is factory. But there are also other application areas. So this is a company, Media Broadcast, as the name suggests. They are supporting media events. They bring connectivity to parties, to football games, and so on. So this means they are, for instance, for us a partner. They provide a commercial offer for this kind of service. But in order to understand how technology could be utilized, they licensed our Open 5G core and integrated, for instance, different radio equipment in order to make this possible. So there's also a fancy video for this from this company, unfortunately in Germany, in German language, but at least you get an idea how this could be commercialized as well. So then we supported this kind of multimedia support also as part of research projects in the city center of Berlin. So here is a very nice video which somehow describes our setup at the Festival of Lights. It's a big show event in Berlin for some nights. The city is illuminated and people are coming together. And for this, we provided some kind of connectivity in an ad hoc mode. Most important for us in these days is our nomadic node. We work since long with the satellite infrastructure providers and the European Space Agency. So here, we equipped this truck from the Bundeswehr University with our 5G core and attached some radio equipment with this, and the satellite backhaul provided the connectivity for fancy demonstrations at different places. And this has led to a big German project. We have a lot of wildfires like you face in California, for example, near Berlin. And we are now working together with the local firefighters department in Brandenburg, which is the state around Berlin. And we will set up a local nomadic 5G network, which enables drones and firefighting trucks to be controlled in an area, very rural area, where there is no public 5G coverage. So we are doing this with different companies and the fire department over there. Last but not least, Open RAN is a very important global topic. And we are now launching in the beginning of January a very huge project funded by the Ministry of Economy in Germany to create an ecosystem of players, of companies who are building functional components for this multi-vendor infrastructure, which is supposed to be an own ecosystem in the next 3 years, so that Europe and Germany could build up their own infrastructures without any dependency from remote international players, if needed. We will see how far we come, but this is basically what we do. So what you should have learned is there are more slides in this deck. Take a look at the video links to get some impression. What is the state of play? What have we done? We are typically working also with network operators. There's no doubt about this, but we have identified for ourselves there is a much bigger market for innovative solutions when we focus on campus networks, because in the end, it will be the hospitals, it will be the John Deeres and those who are in agriculture, it will be the Bosches and the Siemenses in the factories who will create fancy applications, and they need a very innovative infrastructure. So, and we are working with these companies. Many of those already have licensed for their own research lab, our open 5G core. And we think we can do exactly the same over there in the US. We have Fraunhofer US over there at your place, and we are going to build up a reference test site in the very near future. But you do not necessarily have to come to this reference site to do your research and your prototyping. We can also bring this software and help you in planning your local network at your own place. And then you don't have any worries about IPR and stuff like this. So we know how to build up networks. We know the industry. Our 5G core is highly interoperable with many different vendor products. And so we are not shy. We know how this works. And there are some slides which illustrate that this journey of local networks will continue, particularly with 6G, when we talk about terahertz communication, which is an indoor communication technology which unites communications and sensing and positioning, and even more crazy applications become possible. That's it from my side. I'm ready to take any questions, and I hope you have found it interesting.
Thank you, Thomas. That was big, as I promised. Big numbers, big visions, and big things coming. That's what I understood. We now have some time for questions from the audience. Again, the notice that Eventbrite had some issues this morning, so that's why many of you probably couldn't jump on this webinar when it started, but be sure you get the link to the video. And Thomas mentioned several times the slide deck. You will also receive the slide deck, which is carrying more information than we could possibly present in this shorter time frame. Are there any questions?
While you are looking for the questions, Marcel, let me also introduce my colleague Marius Corici, who is also one of the attendees. He is my deputy and particularly our 5G mastermind. So basically he's also here and could help in, let's say, assisting in the questions, but also he will be one of those guys later on when we do more on the US side, working with our friends and partners.
Hello, everybody.
Hi, Marius. I see some question in the chat. Let me ask the question, and you may answer. Will the 5G private networks interface Authenticate and hand off to 5G public networks?
Good question. In principle, there are some activities in place to enable this. It's not yet fully standardized. And honestly, in the past, network operators were not really happy in allowing this kind of, let's call it roaming, what it literally is, because they have really seen this kind of local private networks as competition. And therefore, network operators are typically trying to provide a local network for the factory. And their asset is that there is also connectivity in the public area. But in principle, it is becoming possible because now network operators are recognizing that there will be more and more quite big and important enterprise networks. And in this regard, this kind of interworking is possible. Now the question is really interworking. What does interworking mean? Is it in the end, you are allowed to make calls to the outside world or to open data sessions to the outside world? Or is it that some of your services you need, tracking of devices, is continued in the public network region? And this is something we really have to distinguish and look very careful at, because a key target for campus networks is data should be local and all communication should be very controlled going in and out. You are muted.
No, I was just asking if this answered the question. I suppose it did. While waiting for other questions, I'm wondering, like, I mean, you were talking about all those different sites where 5G is possible or applicable, and where it's actually required to move towards the next steps, like Industry 4.0 and those alike. I was wondering if there's any scenario, any site where you would say, well, this is not a good fit. So is there any exclusion? And you mentioned arenas and harbors and all these different sites. So I was wondering, is there anything where you say, okay, that might not be a good fit?
I personally would say it is depending on the specific location and the kind of frequency you want to use, right? So there are some environments where, because of technical devices being in, there might be distortions. Basically, the factory floor is a very extreme environment, and this poses quite a lot of challenges in order to provide the right connectivity and to select the right frequencies in order to avoid this kind of disturbances. But in principle, as I said before, 5G, and please recall the 5G triangle. This means it's a technology which can really transport a lot of data, ideally can connect many devices, and could be designed in a very reliable way. I can't really imagine application use cases where this might not fit. The energy footprint is an important thing to consider. And therefore, some people might think that a cable communication might be better, but people want to get rid of the cables, right? And this is the challenge. So basically, I'm not sure whether there is a specific area where this might not work. Particularly, at least I hope you have understood, 5G is a technology which could work in many different frequencies. And particularly, there's also a new thing which is called Li-Fi. So this means even you are using invisible light for the connectivity of some smart devices. And it's particularly a 5G access network technology. So in principle, 5G will become the common denominator for communication platforms. I'm sure about this.
So we should have the whole state of South Carolina attending this webinar, because everybody will come across this technology. That's what I heard.
For sure. And let me add one statement, because people might be confused about the upcoming notion of 6G. Because then people might say, hey, 5G, at least at this point in time, is not fulfilling all what I want. 6G is promising to do all this and even more. I wait for 6G. So 5G will evolve into 6G. So the storyline is, with 5G, we have entered the world of software-based networks. Mm-hmm. And this means we can change parts of the network in order to improve it, And in this regard, no one should be afraid that people are now talking about 6G. 6G will be deployed in terms of products in 2030. And so we have still a long time that 5G will finally become a 6G infrastructure. And therefore, yes, coming back to what you said, I'm sure everyone, not even in South Carolina, but everywhere in the States, will sooner or later face some 5G.
And speaking of now, what would you say are your typical customers that ask for such a test bed to test out and prototype?
On the one hand, we have those who are building factory infrastructures. So particularly we see that manufacturing really is the biggest domain in this context. On the other hand, let me say that we also see a very strong increase in safety companies who need some connectivity in some areas like fire departments and so on. But when we categorize who is it really the enterprise, or is it a technology supplier or an integrator or even an operator? I would say probably 20–30% of our customers are currently 30 plus international network operators. So not only the Germans, but all over the show. Then we see quite a lot of kind of equipment manufacturers, being it antennas, so radio equipment manufacturers and system manufacturers who want to have a kind of lab infrastructure of a carrier-like network. So I would say this is probably another 30–40%. We have some customers who are, let's say, needing really a research infrastructure. So these are academic organizations. I would say this is so applied research organizations and universities. So this is the other 30% left, I would say. And all of those, and I think you know as it is, all of those industry players, they want to have an vendor-independent prototype, which allows them to really go over the edge of functionality. Because a big problem of products, which in these days you can buy from the big vendors, being it Nokia, Ericsson, I don't mention Huawei in your area at this point in time, but these products are closed boxes. You can't easily change and adapt to very advanced functionalities, to implement advanced functionalities. And this is where our software, which we license as source code, is particularly of interest, because it allows really to adapt to very specific things in order to see, is this working? And we are focusing on an end-to-end connectivity for specific applications then. Yeah.
So thinking of South Carolina, if a company now decides, hey, this is something that we also need to work on with, how should they, what should they expect? How should they approach?
In principle, the question is, so first of all, what is the purpose? What is the business of this company? Is it a company which particularly also has a strong IT department, which has already in the past built up and run a very strong IT infrastructure, like a complex Wi-Fi infrastructure? Then I would say, okay, this kind of department could license our software, get some training from us, and then play around. We can help in addition, because what we do, we license software, we do training, and we help also in the setup of the network infrastructure, because you in the end have to decide what kind of spectrum, what kind of base station, what kind of end systems you want to interconnect for specific use case implementations. So if this is a factory plant or mining or agricultural company, then that would be a setup. If we talk more about a company who currently builds a fancy Open RAN base station, so currently we have quite a lot of these companies approaching us. Hey, we are building an Open RAN base station. We need now a core network which particularly implements the counterpart for these interfaces. Then also this company, deep in the area of knowledge, they just license, right? So on the other hand, it's, I guess, in combination with you and then local partners. So this is what we do in Germany. You find this slide on Media Broadcast. Media Broadcast is a company which provides this multimedia services, but this company also works as a kind of integrator. They plan networks, they build up networks, even they could run networks on behalf of an enterprise. So this means when a kind of enterprise approaches us and they want really a very complex setting, then we work together with Media Broadcast or Smart Mobile Labs, just two examples of integrators. And then they get a whole kind of campus network infrastructure, which finally will be operated by Smart Mobile Labs or Media Broadcast, not by us because we are researchers, right? So we can't sell products, then we need a spin-off.
The Fraunhofer model, yes. We're getting very close to the hour. Oh, the hour's already passed, but I'd like to pose one more question because I see the 6G logo, which I learned that is made up by you, so it's not an official one. First, 5G, what does 5G stand for? And then second, what's the difference between 5G and 6G?
So let's say I can take it from the stupid angle and could say these are just numbers, and the numbers are somehow numbering the generations of mobile communications.
That's
right?
the right way to say it.
So, but on the other hand, we can say 5G in the end is opening the communications infrastructure, as I mentioned it, from massive multimedia applications towards this ultra reliable Internet of Things communication infrastructure. And particularly 5G is enabling the industrial IoT. 6G is probably the network infrastructure of sensing. The technologies, and I mentioned it already, terahertz communication is enabling a completely new kind of applications where we will have holistic communication. Our user interfaces might not be anymore any smartphones, but we are interacting via gestures. We can sense through the radio access network, we can sense if people are still breathing, if people are entering your building, or a patient in the bed is not feeling well. So this is just some example. But in reality, we would say, my storyline, 6G is a successor of 5G in the sense to fulfill all the promises 5G has posed on the table and is really implementing this. So every second generation, and you can compare, 2G was really the first digital voice network all around the world. 4G was substituting 3G in the sense that we have seen really a good wireless internet. 5G, we are seeing that it is mushrooming in all application domains, but not yet really being this universal Swiss knife in connectivity. 6G will this reconnect everything in a secure, power, efficient, sustainable way. This will be the difference between 5G and 6G, because the sustainable development goals are an important requirement for 6G.
And Fraunhofer will stay at the forefront of this technology as well.
We are, let's say, you might have seen in the media, Germany has launched some 700 million euro at this point in time for the new 6G program. So these projects have started 2 months ago. Fraunhofer itself has started its own, what is called 6G flagship project, Sentinel, in the beginning of this year. We are part of it. So we are working already on 6G, but we have to be correct. There is no code currently available for 6G. Currently, we try to understand what will be the market demands, what will be the service visions. You have heard about the terahertz base station. So to have a terahertz base station in your hand, this will take another 3 years. A prototype probably in 2 years, in the sense that you really can connect it and use it with some devices.
So we will do a couple of webinars in this meantime, I guess.
For sure, for sure. But I think at this point in time, we should particularly address the opportunities we have with 5G. And as said, 5G officially launched 2 years ago was not really a killer infrastructure, right? So because it doesn't provide fancy services as we have heard in the announcements of vendors and operators. But now with the second generation of products and the standalone technology, we see for the first time really cool technology. And we see lots of end systems, which was also a problem in the past. And particularly when we talk about end systems, I don't talk about smartphones. I talk about kind of modems, which you can inbuild in your robot systems and devices you want to control. And we have now, you know, I compare it with a Lego brick toy system. I don't know, you should have it also in the US, right? So you have
lots
now
of in the kids' room.
In the kids' room, exactly. So, and you have to imagine that now you have really cool building blocks, and you can create really crazy cars, crazy drones, crazy whatever you can imagine. So it's already, it's now really the time to go with this equipment into the shop floor, into the hospital, into the agricultural truck in order to make things happen.
And wouldn't that be great if the state of South Carolina pays half of the labor for getting towards this at your company? So that's my kind of closing remarks. Reminding everybody here that we have this substantial cash match for doing any projects. And of course, if you're interested in this technology, just give us a call. We are collaborating, of course, with the German side, and we will be able to give this technology to you. Are there any more questions? Are there any more comments? I see a comment here from Craig Kinley. Stay close to in-building network companies such as Digital Bridge, as they usually already have the rights and relationships to building wireless providers to provide 5G, 4G, 6G public networks with carriers. I suppose that was a comment to the question earlier. I guess that closes this session. Thank you, everybody. Thank you specifically, Thomas, for giving us this broad overview of this technology. We will hear more from that in the future. I guess I wish everybody a nice December, and I hope I see a lot of you in the next year. Let's hope this year is the coming year is getting better than the last one and the one before. And thank you, everybody.
Well, I'd like to thank Thomas for an excellent presentation and Marcel for an excellent master of ceremonies. So thank you, and a nice, robust recovery. So
thank you, everybody.
Okay.
Thank you.
Bye-bye.
Thanks, everyone.
Bye-bye.